Hello and welcome to the section 8.3 lecture. Today we're going to be talking about solving systems of equations using elimination. Now, when we're looking at elimination, sort of the main idea is that if we can get rid of one variable, so if we can get rid of one variable, then we can solve for the other variable. And then once we have that, we can then figure out our other variable as well. So the one that we canceled out or the one that we got rid of. So looking at how to use the elimination method, we want to sort of what I consider, it says to arrange the equations with like terms in columns. And what I think of when I'm looking at that, I want my x's, my y's, and my equal signs stacked. Most of the time when you're looking at using elimination, you're going to be thinking of equations that are in standard form rather than slope-intercept form. It can still work, but they both need to be in the same form in order for it to work. Okay. Then we want to multiply one or both equations by some number to obtain coefficients that are opposites for one variable, for one of the variables. And we'll take a look at that. That's the main sort of hurdle when it comes to using elimination. Okay. And then they say to add, and notice that they also said coefficients that are opposites, opposites and add. And we're going to look at multiple different ways to do that, where maybe you don't need coefficients that are opposites. Having coefficients that are the same would work as well. And to back up a little bit, the word coefficient, if we've said it a lot now, that is the number that's being multiplied by a variable. Okay, so then we want to add those equations. Combining the like terms should eliminate one of the variables if we've done that correctly. And note that can either be done with addition or subtraction. And we'll look at both of those. Personally, I am partial to addition. I do like using addition better, but subtraction works as well. And then solve for that variable. After you've eliminated one of the variables, solve for the other one. And then we want to do the normal thing with systems of equations. You've got one answer, find the other. Okay, that's kind of what step 4 is, and then they have step 5 as checking our solution. Just in the interest of time, I'm not going to be checking, but it is a good idea. There are a lot of problems here today. I want to go through all of them in the video so that knowing that we're not going to get all of the problems done in class, that I do want you to be able to see the final answers that we get from all of them. I have an idea of what I want to do in class, but it's definitely not solve all these to their fullest extent. So here we go. So when I look at this first one, I see that I have 3x minus y equals negative 6, 6x plus y equals negative 12. So x's, y's, and equal signs, and even numbers are stacked on top of each other. Okay, that's step 1. If it's not written that way, you have to go back and write it that way. And like I said, these are both in standard form. That's kind of the norm when looking at elimination. It's not required, but it's what you're going to see most often. So looking at this, now trying to think about getting rid of one of the variables. And I noticed that if I just add these two equations, old school addition, straight down in each one of my columns, I'm going to get 3x plus 6x, which is 9x. Negative 9 plus positive 9 is 0y. and negative 6 and negative 12 is negative 18. Now, the trick here is that 0y doesn't matter. 0 times anything is going to be 0, so we can really just eliminate or get rid of that y term. In practice, what I would probably do is say that those cancel. Now, I'll get to in a second that I don't really like to, really cross those out. I can think about crossing those out, but I'll show you why in just a little bit. So now I have an equation. I have a pretty simple equation. 9x equals negative 18. We're dividing by 9, and we get that x equals negative 2, which was pretty easy. I will say that in elimination, most of the time solving for your first variable is easy. And if you remember back to substitution, solving for our first variable was hard. We had to solve one of the equations, plug it into the other equation, and then we had to distribute and solve. And there was a combined terms in there. There was a lot of stuff in there. Here, finding my first equation was pretty easy. The trade-off being finding my second variable is a little bit harder. Notice I don't have any equation that says y equals some stuff. I don't have that. Whereas I had that built in substitution. I don't have that. So I'm going to have to use one of these equations, and this is why I don't really like canceling this out, because now those negative 9y's and 9y's exist. But I want to pick one of these two equations, and it doesn't matter. You can either pick, equation 1 or equation 2. Either of them should give you the same answer for y when you plug your x value in. I'm going to pick the top one. We're going to go 3 times negative 2. So there's kind of like a substitution going on here, but it's not the process of substitution for a system of equations. It's just, that x equals a number, put that number in for x, and we're going to find out what y is. Okay, so I am just calculating now, solving an equation, and I think the answer is going to be relatively trivial. I'm going to add 6 to both sides, and we get negative 9y is equal to 0, which means that y is equal to 0. Important thing for me, for you, I guess, in my class, I always want to see the answer as the ordered pair where those two lines cross. That reinforces that idea that all we're looking for is that point where two lines cross. So we get negative 2, 0. And so that was using addition because I had opposites. I had these opposites on my y's. I could use addition and they would cancel out. If I have the same number right here, so here I have a negative 7y and a negative 7y. Notice everything's already stacked, so I'm good there. But if I have the same number, I technically don't have to change anything in the equations, okay? But if I add them, let's just see what happens if I add them. We get 4x, negative 14y, and negative 40. So doing that did not get rid of any variables. So addition's not going to work. We want to be using subtraction here. Because if I have the same number and same sign, I want to subtract. Now the trick with this is that I'm subtracting every column. I'm thinking about x, or 1x, minus 3x. That's negative 2x. Negative 7 minus negative 7. Negative 7 minus negative 7 turns into plus a positive 7, and that's my 0. So those ones do cancel out. And now finally that's going to equal negative 24 minus a negative 16. So that's really turning that into addition, and that would be a negative 8. And now I can divide by negative 2. Again, the easy thing in systems, or the elimination method, is finding your first variable after you cancel, or I should say after you eliminate. And we get, it looks like x is going to be equal to 4. Now I go back to one of my original equations and try to find out what y is. I'm going to pick on the top one because it looks like 4 minus 7y is equal to negative 24. When I subtract 4 from both sides, I'm going to get negative, I'm trying to do too many things at once. I'm going to get negative 7y equals negative 28. And when I divide by negative 7, we're going to get that y is equal to 4. That's kind of a symmetric answer. The x is 4 and the y is 4. Okay. Let's try a couple down below. Okay, and we'll do the kind of try to figure out which operation we need to do. We can either add the equations together or subtract them. Those are the only two things that we talked about right now. Looking at the one on the left here, it looks like I have opposites on my y's. I have opposites on my y's. So if I add those, I will end up with 0y. And that's what I want to do. Negative 8 plus negative 1 is negative 9x. Y's will cancel. Negative 17 plus 26. I think that's going to give me a positive 9. Divide by negative 9. And we get that x equals negative 1. Now we can use that in either equation. I'm going to pick the bottom one. Numbers are a little bit smaller, and something kind of cool happens with my plugging in my 1. That's going to turn into a positive 1. Minus 5y equals 26. So turning that into a positive 1, we'll subtract 1 from both sides. And then we can divide by negative 5. And we should get that y is equal to negative 5. So I have x at negative 1, y at negative 5. Okay. Now let's look at our next one. X's, y's, equals, numbers all stacked. That step 1 is done. And now I need to figure out which one I'm going to cancel out. In any equation, or in any system of equations, you could cancel either variable. We're just going to try to look for the one that's easiest to cancel. Now this one, I notice that my x's have the same number. If they have the same number, I want to subtract. 2x minus 2x is 0. 4 minus negative 2 turns into 4 plus 2, which is 6y. Negative 22 minus 26 is going to turn into negative 48. Now for the easy step to find one of the variables, it's usually the type of equation that you're left with. That's going to be negative 8. And now with y at negative 8, again, you can pick either equation. It doesn't matter. I kind of like the bottom one a little bit better. And so I have 2x. Note that I am plugging in for y. Minus 2 times negative 8 equals 26. So I have 2x. Negative 2 times negative 8 is actually positive 16. And that's going to be 26. I'll subtract 16 from both sides. And we get 2x is equal to 10. Divide by 2, and we get x is equal to 5. So my answer here, x is 5, y is negative 8. Okay. Let's go and move to the next page. So I do have some notes up here that kind of help us understand what we're going to have to do. And I believe I have 4 of these. I do. Okay. So for the 2 that we're going to try, the first thing that I want to do is I want to figure out what can I cancel out. Everything's already stacked, so I don't have any of those things to show us. So everything's already stacked. But what do I want to get rid of? Obviously, I don't have any numbers between x's and y's that are the same, so I can't just add or subtract. I'm going to have to do something first. Okay? I'm going to have to do something first. And what I'm going to do is I'm going to multiply everything in one of the equations to make one of my numbers match up. Okay? What I'm going to do is I'm going to take the top equation and I'm going to multiply everything by 2. The way that I keep that straight in my work is I put it on top since I'm multiplying the top. And I'm going to multiply it by 2. Now my plan for that is that 9 times 2 is 18. Technically, negative 9 times 2 is negative 18. So then I'll be able to eliminate x's. Okay? There's no easy way to turn 7 into 10 because all we can use is multiplication. So this is going to be negative 18 x negative 14y equals negative 38. And then I'm going to rewrite the bottom equation. I'm not changing that one at all. And now since I have opposites, if I add, those will cancel out. Negative 18 plus 18 is 0. Negative 14 plus 10 is negative 4y. And negative 38 plus 22 is negative 16. Divide by negative 4. And y is going to equal 4. That's great. We have y. Now we technically have 3 options for x. 3 equations that we can look at to solve for x. As a rule of thumb, I'm never going to use an equation that I made for one simple reason. Well, I guess 2 simple reasons. The first one being my numbers got bigger. All of my numbers got bigger going from this equation to this equation. The other thing that I kind of have a hesitation about, this is an equation that I made, not an equation that the problem gave me. Now, it's a really weird quirk that I have, but I don't want to use anything I made. The issue with saying that is I'm actually going to be using an answer that I came up with from that equation that I made. So in the end, it probably wouldn't matter. Okay, but I just have a reservation about using anything that I made. I'm going to stick with what the problem gives me. I like the bottom one because they're all positive. 18x plus 10 times 4 equals 22. 10 times 4 is 40. And if I subtract 40, that's going to give me negative 18. And when I divide by 18, that's going to give me negative 1. So my answer, negative 1, 4. Sometimes multiplying one equation isn't enough. Sometimes I'm going to have to tweak both equations a little bit to get coefficients that match up or that are opposites. And when I can, I'm going to force them to be opposites, and I'll show you why in just a second. Because again, I would rather add my equations together than subtract. Remember when I had a subtraction out here, I had to think like, okay, negative 14 minus whatever's down here. And so that's just added like something that I can mess up. I'll be completely honest. I've messed it up before. And so I don't like to subtract if I can avoid it. And technically, if I've already sold out that I'm going to be changing my equations, I should never have to subtract because all I would have to do is multiply by a negative whatever I was multiplying by. and then I could add them. And we're going to take a look at that on this one. Because I noticed that both my x's and my y's, they're all positives. Okay? And it really doesn't matter which one you want to cancel out. If I had the time and honestly the effort to do so, I would cancel out both of them and show you that it doesn't matter. But what I equate this to is like finding common denominators. Like saying, let's say I'm picking x's. I have a 2 and a 3. So that's like going to be the same process almost as saying I have 1/2 of something plus maybe 2/3. It doesn't matter what the numerator is, but I'm looking at the denominators from this 2 and this 3. And in adding fractions, I have to have a common denominator. All right? And I'm kind of doing the same process. So what would the common denominator between 2 and 3 be? Well, it would be 6. And then multiply, and to turn 2 into 6, I'd multiply by 3. That'd be 3. And to multiply, or to turn 3 into 6, I multiply by 2. So 2 times 2 is 4. That's the process for adding fractions. I guess you can't see that, can you? My face is in the way. So that's that process for adding fractions. But what I want to do is I want to do it for a system of equations. I'm going to do the same thing. I'm going to make these x's 6. And in fact, I'm going to make one of them -6. And it's totally up to you which one we want to do. But notice to turn 2 into 6, I had to multiply by 3. So I'm going to multiply this equation by actually -3. I'm going to make this one my negative. And I'm going to multiply the bottom equation by 2, because to turn 3 into 6, I multiply by 2. So 2 times -3 is -6. 5 times -3, sorry, that's -6x. And I am going to be covering up my work here, so let me move down just a little bit. 5 times -3 is -15y. And -10 times -3 is +30. And you still can't see that very well. There we go. Now, on the other one, I'm multiplying it by 2, so I'm doubling all of these. That's going to be 6x plus 6y equals 24. Now that I have opposites on my x, I can add these equations and those will cancel. -6 plus 6 is 0. -15 plus 6 is -9. And 30 plus 24 is 54. Divide by -9. And we get that y is equal to -6. Now, just like before, I actually have 4 options for which equation to use. Again, I'm going to pick one of the earlier ones because these ones, the numbers just got bigger. And I don't want to deal with bigger numbers if I can avoid it. I'm going to pick the bottom one here. It really doesn't matter. 3 times -6 equals 12. 3x minus 18 equals 12. Add 18 to both sides and divide by 3. And we get that x is equal to 10. So my coordinates where these two lines cross, not -6, 10. It's going to be 10, -6. And there we go. All right. Go ahead and pause the video and give these a shot. At the very least, figure out which equation you're going to multiply what by. Hopefully you had a chance to take a look at those. For me on this top one, I could either get rid of x's by multiplying the bottom equation by 3, or I could get rid of y's by multiplying the top equation by 2, or possibly even -2. It doesn't really matter. I'm actually going to multiply the top equation by -2. Again, it doesn't matter. You could multiply the bottom equation by 3 and everything would work out. It's just changing which variable you're trying to get rid of. So multiplying by -2, that's going to be a -6x, a positive 14y, and that's going to be a couple less than 60. How about positive 58? For the bottom one, I'm just going to rewrite it. Notice I didn't put anything down here because I'm not changing that one. -x minus 14y equals -23. Now that I have my y's with opposite coefficients, I can add. -6 plus -1 is -7x. And 58 minus 23, really, 58 plus -23, looks like 35. Divide by -7. We get that x is equal to -5. Using x is equal to -5, maybe in the bottom equation, even though there's a lot of negatives there, I have -5 minus 14y equals -23. That's going to turn into a positive 5. I'll subtract 5 from both sides. Over here they cancel. I get -14y is equal to -28. Oh, look at that. It's going to work out real nicely. Divide by -14. Sorry about that. And we get that y is equal to positive 2. So the coordinates, -5, positive 2. Let's go there. Last one we're going to look at here. I'm going to scroll up a little bit so that it doesn't get covered by me. We do have to multiply both equations by something. There's no good way to get rid of one of the variables just by changing one equation. I can't turn 2 into 7. I can't turn 6 into 9. So I am going to have to change both of them. And for me, I think about I could turn both 6 and 9 into 18. I do need to turn one of them into a -18 to make things a little bit easier. And we'll figure out which one that's going to be. I know that I'm going to turn 9 into 18 by multiplying by 2, and maybe I make that one my negative. And I'm going to turn 6 into 18 by multiplying by 3. All right, multiply this one by -2, so 2 times -2 is 4. 9 times -2 is -18. And -2 times -2 is positive 4. Down below, multiplying by 3, we're going to have 21x. We're going to have plus 18y. And we're going to have 21 there. Since I have opposites here, I can add. That's totally okay. And that looks like it's going to give me 17x. Did that really happen, or am I just, yeah, I'm losing it. Okay. This is a -21 over here. I didn't think I made any ugly ones. 17x, my y's cancel, and I get -17 over here. That's a good thing as opposed to what it was going to be. X is equal to -1. Now we'll find y. Maybe we pick on the top equation. 2 times -1 plus 9y equals -2. That's -2 plus 9y equals -2. And when I add 2 to both sides, I get 9y equals 0, which is going to give me that y is equal to 0. So the coordinates, -1, 0. And that'll be it. As far as practice problems go, I'm going to go ahead and say probably stick with the odd and probably number 3 on the application. So we will practice the odds and application. Just number 3 would be fine. All right. Good luck on those. Have a great day, and we will see you in class.